Alright, thank you very much for coming and welcome to our concept presentation for 2014. My name is Michael, I'm the project manager this year, and I'd just like to welcome you and thank you for coming down, and hopefully we get some good information about this. This evening we'll have all of the area leaders giving a presentation on the concept for this year, and then move on to some discussions, and we've got some drinks and refreshments outside for us as well. Before I hand over to Rowan, our technical director, to get started, you'll hear today a lot of the reasoning behind a lot of the decisions that are made for the concept has been budget, financing or costs related. I think it's pertinent for you to know, and I please ask that you don't make this public knowledge. At the moment, our bank account lies at negative $12,126.37. A lot of that is as a result of carryover costs from last year's bill, but that is significantly lower than it has been previously, and a big restriction on a lot of what we're doing, so please bear that in mind. But without further ado, I'd like to hand you over to Rowan, our technical director, to get started today. Thanks.
Cool. So I'm Rowan, I'm technical director. I'd just like to welcome you all here as well. Like Michael said, we do have a bit of a financial problem this year, and it's led to a lot of the decisions that we made through the concept period. As the design stage starts on Tuesday, we would like everyone's opinion on the decisions that we've made with respect to with respect to the concept, and any advice you're willing to give to us. A quick overview of the car that we're doing. I'm going to be giving a quick overview of the car that we're going to be designing, and then pass over to the area leaders to sort of finish off the explanation. So our vision for the year is to be the driving force of innovation in FSAE, which sort of ties into the vehicle dynamics concept, and I'll let Raf talk about that when he comes up. Tony Tang is going to be talking about the engine selection that we've made and what we plan on doing with the powertrain setup. Tony Hattie is helping Tony Tang with the electrics of the engine, and then going into power management of the electrical system and data acquisition for the VD concept. Lindsay and Damon are both the two youngest leaders that we've got on the tech team this year. Lindsay will be looking at the chassis design and ergonomics study, and he's going to be, he joined early last year and spent a lot of time with the design and manufacture of last year's chassis. And then Damon, who's the aerodynamics this year, the aerodynamics leader this year, he's got a pretty cool aerodynamics concept that we're working towards with Dylan. And yeah, just a quick overview of the constraints that we've got, which are the budget, which has largely influenced all of the decisions that we've made. And we are still hoping to have a top 5 finish and a sort of compressed timeline so that we can get testing and everything done in time as well. I'll now pass over to Lindsay to give an overview of the chassis for this year.
Hi, I'm Lindsay Wood, the chassis leader for 2014. Alright, as Michael Miller discussed earlier, our biggest constraints are restricted budget. Secondly, we've got an accelerated timeline, hoping for testing in October if possible, to allow us to alleviate any issues we have with the chassis and have a good amount of driver training for competition. And finally, we've got differing geometry with this year's concept, which I'll discuss later. Alright, so after this, our major goals were to reduce opportunity cost. So this is not just adhering to our own budget, but if possible coming in under budget. This allows us to reduce opportunity costs in other areas. In other words, allocate more money to areas such as VD, where the money may lead to a bigger performance benefit. As a corollary of this, we aim to effectively utilise sponsorship and student resources. So in other words, manufacture in-house when we can and use existing materials. Thirdly, we're placing ergonomics as a high priority this year. With an inexperienced driver team, an ergonomically sound car will dramatically improve performance and perhaps bring less experienced drivers closer to the more experienced drivers. And finally, a system mass of 40 kilograms to comply with overall VD targets. Alright, so our potential solutions to begin with were firstly the plug-in mold monocoque. This is your highest strength, highest stiffness, lowest weight construction. Unfortunately, carries the highest cost and timeline implications. Essentially, it's a continuous sandwich panel with a high strength core material, a higher shear strength core material, and 2 high strength skins on either side of the material. A mould is constructed from the plug, and then the skins and core are then laid up into that. This is excellent because it gives you, you can integrate it well with other areas, as you can place inserts anywhere in the chassis, as the entire chassis is structural depending on the layout in that location. It allows lesser body work and sleek flowing lines. Secondly, we have the steel space frame. This is a series of steel tubes connected at nodes which allow the forces to be transferred just as tensile and compressive stresses basically. This doesn't have a smooth geometry as the monocoque, and it places restrictions on where you can feed forces in. You can basically only feed in at nodes unless it's quite a low force. It requires additional bodywork and closeout panels and carries a higher cost penalty, though we can manufacture it largely in-house and it has lower timeline implications than the plug mould. Thirdly, the hybrid space frame. We started on this in 2013 as an idea that envisaged the benefits of the plug and mould and the steel space frame, i.e. you could reduce your construction time, negate body work, and so on. The idea is it's a steel space frame with lighter tubes, and the gaps between the tubes are then filled in with a composite panel, which improves your strength, stiffness, and functions as bodywork. This wasn't as effective and carried almost the cost of the monocoque with similar weight to the space frame. Finally, the fold-up monocoque. The idea of this is that you begin with a pre-manufactured sandwich panel available from people like our sponsor Airs, and then slots are then routed in the panel. So beginning with a panel like so, with your core material here, you can then route a slot like so, which allows you to achieve your bend geometry. This doesn't give the same results as a plug and mould monocoque. You constrain to largely flat surfaces unless you form that several times to sort of create a curved surface. You do gain some weakness in the corners where you've compromised the core material, and it constrains you to post-cure inserts, as I'll discuss later. Unfortunately, the only options we were allowed by budget were the fold-up monocoque and the space frame. Alright, so with design selection, we first looked at the mass of the 2 systems. We did this with EI calculations, which are available from people like Excel. Firstly, you need a 200 by 500mm composite panel to be equivalent to the baseline steel tube it replaces in terms of stiffness and ultimate and yield strength. So using the calculations we determined, it needs to be double the strength and equivalent stiffness. So using the calculations we determined a 25mm aluminium panel was of equivalent strength, had approximately 4 times the stiffness. Though with this current concept, we're not aiming for stiffness as a high priority in relation to cost or timeline. The reason for this is that roll loads are they're reacted down the centre line of the chassis on the same axis, so you won't feed torsional loads through the chassis except for in damping conditions. So we're aiming for timeline and budget as a bigger priority over that. So from that we determined that a monocoque with a rear space frame would be approximately 2 kilograms lighter before inserts and brackets, though we believe we could achieve a system mass target of 40 kilograms with either option. The biggest implication, or the biggest issue with doing the monocoque was that we don't have effective post-cure inserts at this stage. Previously we've always used co-cure inserts, so essentially you would have a panel like so, core material here, and your insert would be integrated with the panel. This is very effective at feeding the stresses into the skins, which carry the bulk of the load. When you use a pre-manufactured panel, you don't have the option to do that unless you manufacture the panel yourself. So you would be constrained to using something like this geometry, something like concrete, which then is inside into the panel. This doesn't keep forces effectively into the panel, though there are commercially available solutions. And that is what we use perhaps 2 or 3 the timeline for budget purposes, we elected to go for the splash drain, so the first development of effective inserts was not there. So at this stage, this is the current splash drain exams finishing out. We believe previously we've made a little misinterpretation here. We've been adding additional drain and supports that are actually required. So I've made a little clarification to check on that. We are using a stress sump this year, so there'll be commencement locations to the sump here, upper engine down here, one further back, and they'll all be triangulated to create groups of components for triangulation of the rear roll hoop. Alright, so for manufacture we're going for sponsor source med steel tubes from MHS, and we're also going mild steel over 4130. This is for reasons of if we're notching tubes in-house or welding in-house, it dramatically decreases your tool wear and makes the tubes much easier to work with. Mild steel also has a less severe heat effect design than 4130, so we're less likely to have issues with subpar welds. Secondly, all tubes are will be notched and welded in-house. Previously we've used crack lesion submissions, though this year the budget doesn't allow that luxury. Fortunately, with the geometry of this suspension concept, we have fewer hard points than with a traditional independent suspension chassis. So usually you would have perhaps upper and lower A-arms or a swing arm and a suspension or shock absorber and spring there. So you're looking at hard points here, 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 as well as a damper location there. With this concept, you only have the front, rear and spring locations, and in addition to 4 damper locations. So it's going to be easier to account for cumulative errors that are associated with notching tubes in-house. Something we're also investigating at this stage is adhering to welding codes, specifically Australian standards 1554.1, 1554.5, which is welding of steel structures and structures under high fatigue loading. This would involve things like your welding equipment being certified to a certain standard, records taken of heats and so on, test samples taken to determine any porosity or inconsistencies in the weld, inclusions, embrittlement, things like that, and also doing things like bend test samples. Ergonomics, like I discussed, we're placing this as a high priority, so we're going for an iterative process, as in each driver will get a go in there, in the ergonomics rig to find a comfortable range they can operate the vehicle in. We'll then find a comfortable compromise for fixed locations, such as things like steering wheel height, your leg bay geometry will be fixed from driver to driver. And then after each drive's gone through and we've found a comfortable range, we'll then go back and find a compromise for each of those things. Put each driver through with a seat that suits them. Alright. Now, as a result of the different geometry, we can increase the driver cell length to the limit of ergonomics and rules constraints. So essentially, because we've got different geometry this year, previously you would have a suspension flexure or rear A-arm mounted here, as close to the driver as possible. Though we no longer have that, we have single beam mounted here. So we've swept the entire bump set plane forward and placed a roll hoop here, which is at the limit of the allowable 250 mandated by the rules and how far away the driver can effectively use the wheel. Benefits of this is it places a node immediately here, which will give us much higher or much less compliance in damping. Last year we had that damping load fed into an untriangulated tube of less than baseline requirements, so that should give less compliance. Also, it gives us the opportunity to use an individual moulded bum cert and seat for each driver. At this stage it appears we've got drivers ranging from 1.6 to 1.95 metres. So the use of individual bum certs and seat will allow you to recline taller drivers or sit shorter drivers more upright to comply with the rules such as shoulder harness height, things like that. This is what we're aiming to find in the ergonomic study, especially things like pedal position, comfortable range they can operate in. We found one driver was a large limitation on that, in that their comfortable operating range was about half of every other driver. So it's going to be issues like that that will need to be accounted for in design. Alright, so in conclusion, we're doing a milestone space showing which will be notch molded in-house. This is to comply with our budget and timeline. Future research into inserts and column stiffness on a fold-up monocoque. This is to allow implementation of a low-cost, low-weight monocoque in the future. We've maximised their use of sponsored and student resources, again to comply with budget, and we've modified the geometry from previous years to take advantage of the 2014 concept. Thank you, and I'll pass you on to the next speaker.
I'm Praveen and I'm Vehicle Dynamics Leader for 2014. So in the next 15-20 minutes I'm going to run you through some of the goals, targets and constraints we've had and how we've arrived at decisions. So some of the biggest goals for the team this year was an integrated low part design, a low part count design. We wanted to achieve mode separated suspension. We also wanted to have quick and independent video adjustment of every parameter, easy enough that we'd be able to run a new setup at different event outcome. So you can change between you can change a VD setup between different events. Also a low cost and quick manufacturing, like Millet's mentioned before, our budget's not looking great at the moment. So getting the parts getting the car built for the lowest possible price is one of our highest priorities, and also a quick manufacturing time. Because at the start of the year, based on the discussions we had, we agreed that testing time was going to give us a lot more in terms of performance gain. So this year we've decided to go with the AeroBeam again, and I'll go through what that is in a few seconds. The reason for choosing the AeroBeam is because it's a fairly simple concept that allows mode separated suspension. It integrates a few different subsystems of the car wheel, so it combines an aerodynamic floor, part of the chassis and the VD team as well. And it also has a lower part count compared to some of the other cars that have mode separated suspension that we previously built. So this is an image of last year's VD concept, and this year's VD concept is going to be very similar, but the underbody is going to be slightly different, which Lyle will talk about later. So basically you've got a floor and then two beams, and you've got a roll bar that goes through the center of the car and bolts onto the floor, and that is your roll spring. And we've also got two end springs at the front and the rear, and they handle pitch and they're the springs for pitch and heave. And we've got the floor itself, which is another spring and gives us a low warp stiffness. Cool. So looking at some basic dimensions of our car this year, we aimed for a tipping point of 2 Gs with a center mass height target of about 270 mil. And the numbers we got are 1110 millimeters and 1060 millimeters at the rear. The reason for picking 2 Gs is because we looked at some of the past data from older cars that were running the same tires, and the data indicated that it was well below 2 Gs, and we just added in a little bit of a safety factor there. We also wanted to go for a minimum wheelbase car, but I mean, from past experiences with the previous teams and having chatted to some of the alumni, we've kind of come to the conclusion that it's going to be more of a packaging constraint. So we've kind of narrowed it down to what we've been able to achieve in the past with the similar powertrain package, and that's 1590 millimeters. Cool. Some of the basic weight targets for the car. So we're looking at a unsprung mass of 220 kilos. Sprung mass of 220 kilos and an unsprung mass of roughly 75. This is including the driver as well. Some of the VD targets that I'd kind of like to know the alumni's opinion on. I'll be happy to talk through to other alumni to get some reviews on that after the presentation. So, given our budget constraints, we also have to stick to reusing some of the older parts from some of the older cars to save on cost, obviously. So currently we're looking at reusing 12 gearbox, steering gearbox, and dampers from 13, and also the wheels, spindles, and part of the braking assembly as well. So unfortunately, the person who's doing steering isn't here today because his flight was delayed. But so we're using 12 spare gear system. We're aiming for a non-linear accident with positive accident during initial turn and zero accident under full lock. The idea is to plan or build multiple cams for different accidents that we can possibly test for. Now, we kind of want to use cable steering so that we can achieve the non-linear accident. But cable steering it's something that we've never done before, it's unknown territory. So the plan right now is to build a test rig for the system, and if we cannot get it working in due time, then the contingency plan is just to use the belt crank and tie rods from the VCS as well. Quick review on the front uprights. So the idea is to make it for as low a cost as possible, and we wanted to look into something that required minimum professional labor. Lost plastic casting is what we're looking at using currently. So the idea is to print a 3D print a pattern that we can then use to make a cast upright out of. The only professional labor required here will be boring the holes for the bearings to go in, which can be done at the mech workshop. I'll now pass on to Sam to talk a bit about the brakes and pedal box design.
Hey, I'm Sam. I'm designing the braking system and pedal box on the 2014 car. In the spirit of simplicity and low cost, we're going for a 430 rotor brake design, which is similar to all of our racing cars, trying to carry over as many parts as possible from the 2013 braking system. We're looking at possibly redesigning the brake rotors, especially the 2013 cast iron brake rotors, because they don't feature any thermal isolation between the rotor and the spindle. So we're planning on running some brake dyno tests on a mock-up spindle to try to see if we need to add some thermal isolating titanium spacers onto those, or whether we need to redesign the entire rotors. Something else that we have been looking into, I've been looking into with the person developing the pitch springs, is a pitch-sensitive rear brake proportioning. It's something that they were looking at back in 2007 apparently, but was deemed too difficult under the kinetic system. But we have some very naturally isolated pitch movements of the car, and using that you might be able to adjust the pre-tension on the rear brake proportioning, and you can theoretically neutral brake at whatever deceleration value you want. The deceleration values we've kind of been focusing on, we want a neutral brake at 1.3 Gs of deceleration. That's taken from past data from G sensors on the cars as they've been driving around. We want to have a limiting valve in the car to allow you to not lock up the rear wheels up to 1.7 Gs of emergency braking force. Those are the values we've been looking into previously. They seem to work pretty decently. Something we experienced in Collie is that we found on Marley the car was really suffering under a couple of driver interface issues, including the shifter, the pedal box, the ergonomics. So we're working on a very stiff, low compliance pedal box made from lost plastic casting out of casted aluminium. We're looking at smaller cylinders than ever before to allow us to have a 3-to-1 mechanical advantage on the pedal, which will allow us to not only mount push types underneath the pedal box and have a shorter pedal box than previously, and thus a lighter pedal box, But if we have a 3-to-1 mechanical advantage, any compliance we develop through the pedal box or the braking system will only be amplified by 3 times as opposed to 4.5 to 6 times, depending on if you have a large mechanical advantage pedal box like we've had previously. Thanks, I'll pass it on to Lyle.
G'day guys, I'm Lyle. I'm designing the underbody and rear uprights for this year. So to keep with the theme of low cost and easy manufacturability, the underbody concept this year consists of 4 machines, foam beams that will be bonded together, then skinned, have a composite skin. So the majority of this work will be done by students in-house. The only external processes will be machining of the foam, which we have a sponsor to do. We'll have selective laser melted structural hard points, which we can also get done at uni for free. And there will be, it's a bit different to last year's design. The aerodynamic diffuser will actually be a separate part which will bolt on. To make the manufacture of the structural side of it simpler, and it also allows a bit more flexibility in the aerodynamic design. So this is an image of what the concept's roughly like. So like I said, pretty much all that's done by students. It will need a jig for the layout, which should be a bit simpler than molds we've used in the past. And all the required materials for this are either sponsored or we currently have in the workshop. So the rear upright, again with the theme of quick manufacture and low cost, there'll be another composite part with a selective laser melted core which will be made at uni. They'll be assembled together and be given a composite skin. So I'm guesstimating the manufacture of these is going to take sort of 2 to 3 days each, with the majority of the work being done by students. The only sort of external work is machining of bearing bores and bolt holes at mechanical workshop. So that's everything for the VD side of it. So I'll pass on to Tony Tang now for powertrain.
Hey everyone, I'm Tony Tang, powertrain leader. Just gonna run through really briefly about targets, constraints, and the decisions we made to the subsystems. Alright, so the targets, as everyone else before me said, early finish. And for powertrain team-wise, we want to have really simple design and any carryable parts that we can find from 13. And we plan to finish the car early so we can bring it down to orbital and tune really fine. And performance-wise, we're aiming for good drivability. That means the smooth torque curve down low at around 7,000 to about 10,000 RPM. And 100 horsepower peak at around 11,500 RPM. Now these goals are really heavily dependent on the last year's goals. And good serviceability means that we have good access to the engine and then we can maintain it really easily. And constraints, as everyone else before me mentioned, budget. And due to the inexperience in the team, including the entire powertrain team is consisted of mainly just first year peoples, including myself, that I haven't got much experience in design. And some decisions we made is due to human resource as well, that a lot of us, quite a lot of people in the team really needs to be closely managed. So at the beginning of the year, we looked at a few of the engines that we think of can be really good for this year. So those are the 3 engines. The Seagull 500 engine we looked at really briefly. It's brand new. It came out in the middle of 2013, and it's been saying on the forum that has really good compromise between power, weight, and size. And as we can see, the torque curve is pretty smooth from all the way down to from 3,000 to about 9,000 RPM, which is pretty sufficient for our application. But the problem with this is it's difficult to obtain any valuable information online and forums since this bike is so new. And the high center of mass of this engine, the stroke length of the engine is pretty tall. When we looked at it, we didn't measure it physically, or we actually did, but wasn't well documented. and it's really unavailable. It's unavailable here locally, not available in eastern states. And I actually called out some of the reactors in the US, but there's no sign that they have any of them. So we are forced to abandon this option. And we also look at the Kawasaki Ninja 300. The reason why we look at it is it's really light, small, and cheap. Like for one engine, it only costs around $800. It's easy for packaging since only 2 cylinders. We also look at using the turbochargers we have from last year in conjunction with this, but at the time we don't have anyone that's dedicated to look at this system, so we're still forced to abandon this option. So we'll move back to the Honda CBR 600 black engine that the team has been using since 2012, mainly because the first 2 options wasn't really available, and this option we have more experience, and the potential for modification is big since we've done a lot of work on this in 2011. Fuel selections. We look at the E85 really briefly because we don't see any benefits of changing fuels, and as I said before, experience in the team, lack of knowledge, and the fact that methanol doesn't really mix well with aluminum pipes. So we just we have to go back to the Premium 98. The air intake system, we're planning to take 2012's concept as a template and then reiterate and redesign it. So the idea behind this bolt-on restrictor is that it reduces the cross-section of the intake port to increase the airflow velocity, so we can move the power band down low, which will work in conjunction with the engine modification, which I'll explain later. And other than that, the main priority, as everyone else before me explained, would be low cost and then manufacturability, and utilize any old parts we have in the lab. We also look at the possibility of 3D using the 3D printer to print out entire fragment in multiple parts. So print them out in parts that the printer can handle, and then glue them together using acetone. But we're still looking at that. We're still unsure if the printer is capable of doing that, and the material properties of the ABS plastics can handle that. Moving on to exhaust, we narrowed it down to either using 421 or 42 exhaust system. It really depends heavily on the design of the chassis, the beam, and the fins, as Damon will explain later on about the fins, where they locate. So yes, that's it for that. And the differential and drivetrain, it will be all carryable from 2013, simply because that we can't afford it. The cost from the 2013 drivetrain system is probably to be $4,000. So it's way out of our scope, and we're just gonna do carryovers and buy a new pair of drive shafts to fit the wheelbase, track width. Sorry. Lubrication system. We look at the wet sump and dry sump system, and then we measure the performance and the cost. Well, obviously, if you want a low center mass, you want to move the engine down as much as possible, and dry sump will provide a really low center mass, but we simply cannot afford that much for a application like this. So we decided to move on to a modified wet sump. And these are the 2 concepts we looked at. One is the swivel pickup, and then the baffle was trapdoors. Mark, which is he's a student doing the sump system, was looking at swivel pickup. The idea of that is the pickup will swing around with the oil whenever you're cornering, and then pick up the oils. But we feel like this option is a bit risky, as this system is not really well documented online. It's can't really obtain valuable information. So we decided to go with the baffle and trapdoor concept that the 2013 was doing. So it's proven to work. A lot of motorsport companies have some degrees of successes with this, and the Oh, and the other than that, the baffle, the sump itself will be structured, will be bolted onto the back of the chassis, as Lindsay mentioned earlier, and to the front of the beefy that's sitting at the back of the engine. Oh, and the other thing about this year's sump is that we want to make sure that we don't have to remove the entire engine out to clean out the sump. And cooling, it's just purely carryovers from 2012. The twin radiators we have in the lab is in great conditions, so we're planning to utilize that. Plus the fact that the aero team this year are planning to utilize the hot air blown out on the back of the radiators to the floor to create more downforce. So that will fit the blown diffuser concept. So if they're going to do that, we will have to have 2 shrouds and then 2 fans to make sure the airflow on both sides are equal. And we also look at 3D printing one of the impeller fans as a concept. But the major problem with that is that we have to place the fan behind the radiator. Either the heat generated from the radiator will most likely heat up the motor. So that's still a concept we need to investigate. Gear shift. Nick will be designing the gear shift this year. I'm pretty sure that he knows what he's doing, and then we just make this really simple and plain. So just a simple mechanical system. Engine mods. We're hoping that doing some engine modifications and dyno tunings will make the engine better than what we expected it to be. So these are the few things that we plan to do. Before we went to the we go to the engine mods, just briefly about the engine tuning. The engine dyno that we have in the thermal lab is around 80% ready. So once we got that ready, we just put the engine up and we can get some students down there and learn how to tune and then learn how to simulate, use Ricardo and use the dyno to validate their models. And the chassis dyno we have now, OBO has for us, planning to take the finished car down there before launch or sometime after launch to fine tune the engine with the expertise they have. Alright, go back to the engine modifications. So one of them is the gear shift barrel we're planning to do. So we want to have the gear shift sequence have neutral at the bottom, 1, 2, 3, kicking out 4 and 5. So it's the same as a lot of previous design. The idea of having neutral at the bottom is really easy it will be easier for the drivers to find neutral. As we experienced in Cali that finding neutral sometimes it can be a problem and it's undesirable when during driving that you accidentally shift into the neutral gears. And fourth gear and fifth gear has really similar gear ratios, but fifth gear are actually better at fuel economies, so we decided to take out the fourth one. Alright, and high compression piston is one of the things that Chris was looking at really extensively. So the plan is to buy a set of high compression ratio pistons from JA Pistons. Costs around $400 including shipping. Although we mentioned earlier that we won't have much budget, but the team feels like the performance gain will most likely outweighs the cost. And we're aiming to achieve around 15.5. Well, that number right now is just based on a 5-minute hand calculation. So that will achieve about 10% increase in horsepower. And of course, that 10% horsepower increase would not be achieved purely by high compression ratio pistons. We'll be working in conjunction with various applications, such as engine interior coatings. Our sponsor, Competition Industrial Coating, will do this for us, where we apply some of the coatings to the engine interiors to either lower the frictions or decrease the heat loss by providing thermal barriers. And port shaving, this is a really This procedure has to be carried out really carefully, planning to use JB or epoxy resin to fill out the engine intake ports to reduce the cross section. So we'll hopefully bring the power band down low. And the order of priority of doing this benefit-wise is that we would definitely want to tune the engine, and then if we have spare time, the money, we'll do high compression pistons, port shaping, and then coatings. But given if it's planned well, and given that we have enough time and human resources, the order of doing this will be the other way around. We have to do the coating, port shaping, and the piston, get them finished first so we can do the tunings. So in summary, as you can see, about half of the design will be either redesigned or modified or carry over those parts from 2013 or 2012, and then those few things are the new designs. And that's it for me, and I'll pass it to the next speaker, Patty. Yeah.
Hey guys, my name is Tony and I am the 2014 Electrical and Electronics Vehicle Development Team Leader. I started working on this year's car coming back from the 2013 competition, focusing on the lessons I learned through the team's successes and shortcomings. Going to Melbourne proved to be an extremely beneficial experience for me. Seeing what all the other university students are capable of doing really spurred my motivation to improve the 2014 car. Yes, especially surveying the competitive teams really gave me a good idea of where to start and what needs to be done. So in recent years, the UWAM Motorsport team has focused on understanding the Motec engine control unit as well as the data logger system. Large-scale independent development on the technology of the electronics has been put lower in priority because of the low number of team members. So this year the main goal is to increase the complexity of the loom because we are quite far behind most of the other competitive cars in Australasia. However, when the team encountered the huge scope change early last month, scrapping the 2013 car to minimize the amount of spending, we did have to take a step back in the development of the loom. So this year we will be using only the parts that we currently already have inside the lab. In particular, we'll be reusing the Motec M800 ECU and advanced data logger for engine tuning and data acquisition. We will also be carrying over most of the buttons and switches from the 2013 car, and fortunately, we do have some new sensors which came together with the purchase of our new engine. With regard to the power distribution module, although we do prefer to be designing and constructing a new one, this is subject to the availability of funds, and the plan is to utilize our free access to the university's 3D printer to make a 3D printed case to house the printed circuit board. The plan is also to create a smaller printed circuit board to suppress packaging issues on the car. Similarly, the wiring harness will be fabricated in support of a neat and tidy packaging. The power and data loom will be routed along the same side of the car, so that is, all the wires coming from the back of the car will go along one side of the car, and there will be a hole drilled on the front right-hand corner of the chassis from the driver's seating position, where the wires will enter the chassis. So the wires that need to go onto the dashboard and inside the leg bay to the pedal box will be routed through there. We do still plan to have working wheel speed sensors in support of traction control, as well as wireless telemetry communication for the first time in 3 years. And we also aim to add mixture trim dials as well as a gear position indicator onto the car. And one initiative that we have that's currently in progress is the development of a test loom, which will be integrated with the dyno that is under repair. And cool. And yeah, the test loom will be used to test the sensor inputs prior to installation on the car. Several other goals that we are trying to achieve this year is to improve, to organize a well-documented system for future development. So at the end of 2014, we aim to have a solid handover period over to the 2015 team. And that is to basically provide the knowledge amongst all the team members, so not only in each of their respective area teams, but also across all the other areas of the car, which will be useful to for concept selection and decision making next year. In order to do this, we will aim to have more frequent communication across all the other areas. So for example, the electrical team has been working closely with the powertrain team for concept selection of the cooling system, as well as learning about engine tuning. And we have also implemented damper persistence sensors on the past cars to monitor the damper profiles for our motor separated suspension concept for the vehicle dynamics team. We've also installed a G sensor and 8 pressure tap sensors for our new and exciting aerodynamics, which Damon will cover after this. And the aim of that is just to monitor the airflow below the under tray, so that we can decide which type of wings will be better for the car. And finally, we've also decided on our dashboard concept layout, which has been decided by the electrical and chassis team to prioritize driver visibility and accessibility of the dashboard, because last year the steering wheel was hindering some of the dash's functionality. And more particular to the electrical team, we aim to support the team's goals of center of mass and weight distribution by strategic placement of the heaviest electrical components in the car. So the Motec M800 ECU will be placed under the bump cert below the vehicle center of mass, and the battery will be placed at the back of the car in the beefy, and the power board will be located near the center of the car, next to the starter motor to minimize the length of the high current wires. So in conclusion, the aim of this year is to provide a compact wiring harness and complete this on time through pre-preparation of the majority of the loom prior to the chassis being completed. And we also aim to complete on budget by using readily available materials inside the lab. And lastly, we aim to pave the way for a more advanced development of the electrical system for the future. Thank you. And David?
Hi guys, my name is Dan. I'm the aerodynamics leader for 2014. This year we've got a lot of planned for the aerodynamics package on the car. It's a new and exciting time after the aero team's still pretty young. Last year, not much ended up happening with the aerodynamics concepts.
Alright, so this year we're trying to, as with every year, maximise the downforce to drag ratio of the car and have it adjustable for different events. So you want, in general, you want to have as much downforce as you can pressing tyres into the ground for lateral and longitudinal grip, with as little drag as possible slowing the car down, which increases speed and increases fuel efficiency. Another important thing to mention is to increase drivability in all conditions. There's no point having tons of downforce and tons of grip if it all disappears just when the driver needs it. So we want to make sure that it's effective in all conditions. We also want to reduce manufacturing complexity. That's a weak point last year. We had an aero package design last year that didn't actually make it onto the car because of manufacturing problems. So we want to ensure that that doesn't happen again and we can go to Melbourne with a good aero package. As everyone else has already mentioned, we do have a lot of budget constraints. So aerodynamics has been lucky because we use materials that we've already got plenty of sponsorship for. We can get foam cores machined, and we've already got carbon fibre and fiberglass prepreg available to us. So we will still be actively seeking sponsorship for those materials. Major aerodynamic components on the car this year, either bodywork, wings, underbody, and a vertical fin, which is a new concept we've been working on. Nose cone and leg base cover are the first aerodynamic components to touch the airstream, so they direct and guide air to where it's needed most. Unfortunately, because of our suspension concept with the separated chassis and undertray, we can't really guide air under the car, which is a common thing with cars that have an underbody. So we're going to aim for a low drag nose and leg base. Side pods are another concept we've been working on and very interested in. There's a possibility of having a side pod blown diffuser, which uses energy from the side pods to increase downforce over the diffuser. This is in addition to the main functions of the side pods, which is to provide sufficient airflow to powertrain and cooling components, as well as to protect the radiators and fans from rocks and trackside debris. The engine cover is largely aesthetic, has been in the past, tidies up the engine bay, makes it look nice, but it also directs air over the engine bay. It tends to get quite hot in there, so any cooling helps. Front and rear wings are really what most people think about when they think of aerodynamics packages. It's what you see on lots of teams have a huge front and rear wing. We're going with a similar concept a very standard concept for the front and rear wings, but with a lot of adjustability for different events, so you can run a little angle of attack, have it really open for acceleration so there's not much drag, and have lots of downforce for skid running. The underbody, similar to last year, except it
also the concept is useful in and he's into that. And instead of having your outside tire really have to be like inside tire runway, so sometimes it produces which produce bone across time instead of without possibility of having the adjustable steerable as well.
slide to side to block, which moves side to side as the driver steers. There are a few potential problems. Mainly, susceptible to swing and very light slow arrows. So thank you very much for coming into our
Concept for 2014. I'd like to invite any questions that you have directed to someone that you want the rest to hear or to multiple people now. If not, we have some refreshments and some food outside. Please come and give us your opinions, ask us your questions. We'd really like to know what you think. That's why we've invited you down here. So thank you very much. Do we have any questions at this point? Should we move outside?
I don't have much time here, so I'll make a few comments if you don't mind.
Yeah, please, Fred, please.
My name's Fred Gray. I was on the team in 07. A lot of new faces, except Pete's face. Please help him pass all his units so he can actually get out of here. Anyway, thanks for presenting. I think it was very professional. Don't underestimate how people perceive you as a team. Looking professional and making sure you look like you know your stuff goes a long way, especially when you're out in the real world. So yeah, do everything you can to continue looking professional. I was really impressed with what you guys put on today. Now, it's good that you guys understand your constraint, but don't let your constraints be a goal, okay? So you're talking a lot about cost and time. They're constraints, they're not your goals, okay? So somebody mentioned they want a top 5 finish. I reckon that's a pretty good goal. So have a good think about this going into the actual event, about what you want to portray to the judges and every other team that's out there. Mention cross constraints such as time and cost, but things like cost, you can actually overcome that stuff. I mean, the team's been around for 13 odd years now, since 2001. If you count the amount of alumni that are out there, then people in probably reasonably good earning positions approach them. I myself, I've been away from WA for a couple of years, but it was good to get an email, so come along, check out the concept. If you think about it, if you approach every alumni that's been out there since 2001, I calculated quickly there's probably about 240 of us, roughly. And if you ask each of them to dig into their pockets, a couple $100 each, it'd make a significant contribution to your budget. I reckon you could rack up 20, 30 grand easily, and that would go a long way, if you're struggling with cash. So consider that. I'm surprised you still only got one Botec that you're running. I would have thought you'd have a couple to swap around and, change your settings on the fly. And
We do have 2.
you've got 2? Alright, that's good. What else? Bit of forward planning goes a long way. So I'm looking into what you're presenting us and you're saying you've got all these options. It'd be nice to have, but we'll just fall back on last year's concept. There's no problem in that, but really do understand the cons and pros of the previous year's designs going into the competition, because you'll get drilled by that from the judges. There's nothing wrong, like I said, with falling back on those concepts, but with regards to forward planning, if you feel there's something that's potentially something good for the team for next year, plan it now so that you give people in the future opportunity, instead of just dropping it now and saying, oh, it's too hard basket, well, somebody next year will worry about it. Put something in place. I know now that I'm earning money and paying my taxes, I'm taking interest in the government, and a lot of the governments these days only plan for the short term, but they don't think about the long term, which this team's been going on for a while, so it'd be good to plan for the long term. Like I said, talk to your alumni. There's a huge wealth of information out there. Not just the previous year's team, but talk to the guys from 2001 or 2002. I'm sure they'll be interested in getting involved. Get on the phone with them, ring them up, have a chat with them. I'm sure anyone here, I'll give you my number, Michael.
Thanks.
And if anyone wants, give me a call. I'm happy to sit there and have a yarn for 30 minutes about your design, about how you're progressing. I'm glad you guys have jumped on board. It was a bloody good learning experience for me, and I hope you guys get the same out of it as I do. So the only thing now is time is on your side. I'm surprised this presentation wasn't done, say, 2 months ago. If you're doing a detailed design now, you've got your work cut out for you. But you can plan for that and make sure you have some contingencies in place. But yeah, good work, guys.
Thanks very much. Thank you. Anyone else got any questions or comments, or should we get our
Oh, something. Well, is everything out? There wasn't a whole lot on the car as a whole. Like, what is it going to look like? What colour it's going to be? How fast it's going to go? No hand sketches or anything like that. It would be nice to see what things are going to look like, how things fit together.
You go and get some from that.
Do you have them?
We've got a lot of people's books that are designing parts, and there's a couple that I've done, a couple that we've had people drawing pictures of them. There's almost a CAD model that I'm not too confident in showing everyone yet, but yeah, if you want to come back to the lab, we can go through some stuff.
Have they been compiled? So you're looking at packaging?
Yeah, that's what CAD would be mostly for.
Right, yeah, and you are all more than welcome to come and have a look around the lab. It's a little bit messy at the moment. We've got back from a week down at Collie and it's kind of all unpacked, so everyone can run away and sleep. All the cars are down there, so great if you haven't seen the 13 or the aeroplane and stuff, that's all down there, sure. Yeah, thanks very much. Let's go have a look around.